Okay, so this is going on 134. We are still working with the law of signs, but we're going to look at the ambiguous case. Who knows what ambiguous means? What'd you say? Weird. Oh, maybe. Well, it's open to interpretation. It could have more than one meaning. Okay, so it might be like something you can't really figure out. It could be more than one thing, that sort of thing. So we looked at the ambiguous case when we were doing congruent triangles as well. So let's look at this triangle and let's go ahead and label what we know about it. We know now there's this there's the big triangle ABC, right? And then this is kind of like a, I guess I could have done it there. Since that's my dotted line, this is like another B, make like a dotted B, because it could be more than one thing, right? So basically this side length, I can make the triangle with A, C, B like this, or these two pieces here are congruent because I could flip this out either way, and it could connect in either direction there to make that triangle, all right? That's when we know that, you know, we had the other ones that would work. We talked about side, angle, side, 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 side. What was the one Katie thought was the right one? Angle, side, side. No. This is it. This is the one that's the ambiguous case. So if I have this side length and this angle and this side length, that sometimes, not always, but sometimes I could have a side here, or it could be the same length here. And since this angle doesn't get anchored down, it could swing in either direction, so you could have more than one answer. That's why we couldn't use it for congruent triangles, because it wasn't a for sure thing. Yes, it's possible that they could be congruent, but not necessarily. And in this case, it may not even make a triangle, so we may have like a 0, 1, or 2 type of situation here. Let's see. Here is what we looked at with congruent triangles. Like these two, we have 2 sides and the non-included angle, 2 sides and the non-included angle. It is possible that there are 2 triangles that have that exact same configuration and that they would be congruent. It is possible, however, that could swing in that way. That's what that little diagram is at the top. And then these 2 triangles here have 2 sides and the non-included angle congruent to each other. And are those 2 triangles congruent? Yes or no? Are those 2 triangles congruent? No, they're not. So there's 2 different triangles that could have those pieces of information, which means this angle, these 2 angles right here, could be different in the 2 different triangles. Now look at this, because this is kind of the 2 different triangles overlapping. Angle B is either going to be this angle right here or this angle right here, right? How are those 2 angles related to each other? So either this is my angle B right here, or this is my angle B right here. How do you think those 2 angles are related to each other? Why do you think they make 180? Feel like they do, right? Okay, so look at this triangle right here. What kind of triangle is this? Possibly. Maybe it's equilateral, but it's for sure what? Isosceles, right? So since these 2 sides are congruent, aren't these 2 angles here congruent? Right? And so those 2 angles right there are congruent. And then these 2 angles right here are a linear pair, so they have to be supplementary. So my 2 possibilities for angle B are definitely supplementary to each other. Does that make sense to you? And that's going to be important in what we do with our work, that you understand that. And this is kind of the why in the picture. You don't necessarily have to recreate this picture. I just want to make sure that you understand where those 2 cases come from. It is possible that there is only one case, and it is possible that it's, with our information, we're not even going to have enough information to make a triangle. Okay? So our law of signs, that was pretty simple, right? I don't know where this little extra mark came from here. Well, whatever. So our law of signs, just to make little proportional relationships here, the sine of angle A goes over what? Little a side A. So the sine of angle B goes over little b, and the sine of angle C goes over little c. Pretty easy to remember, right? So if this is angle A, this is little side A. If this is angle B, this is little side B. And then this down here is C, depending on, which triangle I'm looking at. Maybe it's the whole thing. That dotted line would be like the other A, yeah. Dotted A. I don't know that I could do a dotted A, so I'll put it in parentheses. So yeah. Because they're congruent, it would be either one. We good? All right. So we kind of already said this. Remember proving triangles congruent? Remember how we couldn't use side-side angle, right? Because we didn't know for sure that those two triangles would be congruent. And that's why we don't get just one answer. Like the homework that you just turned in, there was only one possibility because those triangles would have to be congruent. Here you got options. Okay, so it's because it's the ambiguous case. That means there could be two different triangles that share that information. So now the ambiguous case means we could have 0, 1, or 2 triangles, depending on what happens. So I'm going to give you the relationships down here. It's a lot to kind of remember and stuff that you have to figure out. Totally not necessary to always test it. I just want you to see that there is a way to test it. It's actually easier just to go ahead and try and work the problem some of the times when angle A is acute. All right. So it says consider a triangle which a, little b, and it should say angle A. The notation on these things really drives me nuts. Are given. For the acute case, so the sine of A, sine is opposite over hypotenuse because H is the hypotenuse there. So H is B times the sine of A. So in order for you to test how many triangles, you'd have to work out that and figure out what the height is to notice their relationships before you even actually do the law of sines, where you could have done the law of sines and figured it out already and not wasted your time on that. Does that make sense to you? Like, it's not necessarily to test it, but there is a couple of these where you can kind of look at it and know. So if angle A is acute, right, so A is less than 90, and then in this case here, you've got little a and little b, right? So if A is less than B and A is less than H, then there is no solution. Okay, or 0 triangles. Here, so this is H, this would also be little a, right? So if A is less than B and A is equal to H, what kind of triangle do we get? A right triangle, and you have one solution. Then we have this one where A is still less than B and A is greater than H. This is when we get that ambiguous case where it could be two different triangles, and this could be two solutions. So when A is acute, you could have 0, 1, or 2 solutions. That's all when A is less than B. If you have A is greater than B, then it's not going to swing. Since A is greater than B, if I tried to swing this back over here, it's going to swing out farther, and it's just not going to work. We're not going to get 2 triangles. So this has 1. So if your angle is acute and your A is greater than B, you only have 1 triangle. But again, if you're confused about which is A and which is B, if you just work the problem, you'll be able to figure it out anyway. Okay? But again, some of us these kind of things make sense. Now, if A is right or obtuse, so if the angle is greater than or equal to 90, it might be worth your time to look at it for a second, okay? Because you can't have 2 solutions. So here you either have 0 or you have 1 solution. So if angle A is obtuse, right, which means it's going to lean out this way, if A is less than B, it's not going to come out far enough to actually make a triangle. Does that make sense to you? So if A is less than B, this is no solution. And if this is angle A is obtuse and A is greater than B, it has 1 solution. Whether or not you test for that, that's up to you. Okay? This one right here should actually be A is greater than or equal to B. Because that could possibly be an isosceles triangle. So it's make this A is greater than or equal to B. That's why I make notes before we come in here. All right. So all that aside, I'll show you how you know when you're just working them. So we have this triangle. The first thing we should do is draw and label it. Okay, so I'm going to draw my triangle. Now, it's okay that they're not always to scale. However, if you at least attempt to make this, since this is an acute angle, look like an acute angle, that might be helpful. It also might be helpful to you to actually make A a little bit longer than C. But if you don't, it's not the end of the world. Like, don't take forever trying to make a perfect triangle. It's not worth it. So here's my angle A. That's going to be 61 degrees. And little a is across from it. And normally, I wouldn't put the variable on here, like if it said x was 55, but I think it's helpful on these because then you can make sure that you know which one's little a and little b and little c, that sort of thing. Now, it doesn't matter where I put the b, as long as if this is capital B, I put little b over here. But it might be helpful to you to always be consistent in how you draw them. Meaning, since the other side that I have, this is actually C, not B, but it doesn't matter, right? Because it's just another side. I'm going to put the other one I know here. So I always have the angle and then the two sides like this. And the more consistent you are with stuff like that, the easier it's going to be for you. So this is a capital C. This is a capital B. That would make this, my lowercase b, 61 degrees. Okay. All right. So I need to find, basically I need to solve my whole triangle, right? So in this case, I am given, is this acute or obtuse? Acute. So I'm given an acute angle, and we're going to figure out how many solutions it comes up with. Don't worry, do you even have a clue what I said about if A is greater than B and H and any of that stuff? Do you even remember that? How many of you, if I said you have to know those things, it would be a difficult thing to actually remember and you get confused? Yeah, okay, me too. That's why I'm saying I showed it to you. If it makes sense to you and you can look at it that way, if you have to always right now we could refer back to it, but if you always have to refer back to it, it's not going to help you any. So if I just show you how to solve it, it's going to be way better than you trying to remember the tricks, okay? So you're going to do this law of sines because this is still the law of sines. I have to use these two, right, because these are the two I have the information of. So I know that the sine of 61 over little a, which is 55, is going to be equal to, all right, well, I have little c, that's 35, that goes down here. So this would be the sine of c up here. Everybody with me so far? Okay, so now I'm going to cross multiply and divide. So I know that the sine of c is equal to 35 times the sine of 61 all over 55. So then we can find the measure of angle C from that. Here's what is important for you to remember to do and get in the habit of doing when you're doing this. Store everything. Okay, I shouldn't say everything. Once you find the measure of angle C, store it, even if you're not sure that you need it, because you're going to need a lot of this stored, and then you won't have to remember if you stored it or not. Because storing is easy. It's something you got to be able to do anyway. So we're going to go in here and make sure we're in what? Degree mode. Okay. So I am in degree mode. Double check yourself. If not, then make sure you are in there. So I'm going to do 35 times the sine of 61, close my parentheses, divided by 55. Yeah. So the number I get, is that the measure of angle C? No. That's the sine of C, right? So what do I do with this? Sine inverse. Okay, so here's the deal. I could store this so I could take the sine inverse of x. Would I ever just type in a few of these decimal places? Heck no. But without even storing it, watch this. I can do sine inverse. And I want to take the sine inverse of what just happened. So I can do second, the negative sign is answer, and it'll take the sine inverse of my last answer. And then that gives me my angle. Okay, everybody with me on that? All right, so now I'm going to store that. Since this is angle C in this problem, I'm going to store it in alpha C. All right. So now that is stored in angle C. Everybody with me? Okay, and then I'm also going to write it down because that's one of my answers. So the measured angle C was 33.819 degrees. We good? Now, because this is the ambiguous case, because this is two sides in the non-included angle, or really anytime you're solving for the angle with the law of sines, you have to check this, because remember, two different things could be happening. That's the 33 degrees, so maybe this is 33 degrees, and then there's another one that would work too, and we got to check that, okay? So here's how we check that. We already know that the two possibilities for angle C are related how? They make 180. What's our fancy math word that's not that fancy for that? Starts with an S. Supplementary. Okay, so they're supplementary, which means they have to add to give me 180, right? So I have my two possibilities for my angles. I could have an acute angle for angle, this is angle C. So the acute one would be 33.819. The obtuse possibility would be 180 minus the 33.819, right? And so on my calculator, I'm going to do 180, and I can just do minus alpha C, and I get 146.81, I'm sorry, 0.181. So this is 146.181. But am I always going to have two answers? No. So this is for sure one of them. That is definitely my angle C. This is only my angle if it would actually work in my triangle. So I know two things right now. I know that this is a possibility, and I know for sure that this is one of my angles, right? So I'm going to take this 146.181, and I'm going to add the 61 degrees to it. That's only two of my three angles, right? When I add those together, what's going to happen? I get over 180. Does it even matter what I actually get? No. All that matters is that that's greater than 180. So this is not an answer. Does that make sense to you? Because I don't have room for my third angle in there. I haven't even found it yet. I don't have room for it. So I know that I only have one possible triangle from this information. Everybody with me? So this is the key here, is that you got to check it. Right? You have to check to see if they both work. So I only get one. Now I'm supposed to finish, so that means an acute angle given one solution. So there's my angle. I also have to find the other angle, right? Angle B, right? So I know that the measure of angle B plus, I don't even have to write that down, or I can write 33 ... plus 61 has to equal 180. And the reason I would put ... or I could just put C is to remind myself that's a stored answer, right? Make sure you're using your stored answers all the time. Very important that becomes a habit to you. So this 146 I don't even care about. I'm going to do, so my angle C, so alpha C plus 61. And then I need to subtract that from 180. So 180 minus that answer. And then there is my angle B. And so what should I do with this right now? Store it. You're going to need it. So I'm going to store it in alpha B because that's angle B. So now I've got the measure of angle B is equal to 85.181 degrees. Everybody with me so far? So what else do I need to find? Side B, right? Because I found this, I got that, I need to find B, which means I'm using the law of sines for that. So I'm going to use what they gave me, just like I used here. I'm going to start with the sine of 61 over 55. That's equal to the sine of B over little b. But I'm writing it like this because I'm literally in my calculator going to use the sine of b. And I'm going to circle it to remind myself I already have it. That's just something I'm doing in my calculator. Because here's the danger. If you write the sine of 85.181, you're likely to use that. And you might get the right answer to 3 decimal places, but you might not, and you don't want to risk that. Okay, so always use your short answer. So now I'm just going to go ahead and cross multiply. So that's going to give me 55 times the sine of b. And then divide it by the sine of 61. And bam. So little b is equal to 62.662 inches. Any questions about that? The only difference between this and what you turned in is that you have to check because there might be more than one answer, and you're looking for an angle using the inverse here where you just used it to subtract on the other ones. Okay, we're all good? Yes? Alrighty. So let's look at example 2. So what kind of angle are we given an example 2? Acute. Okay, so this is an acute angle. And so my triangle ABC, so my angle A they give me is 75. Little a is across from that, that's 51. So this time they give me B instead of C. The letter is really kind of irrelevant. I'm still going to put it here. Because again, the more consistent you are with how you draw this, the better off you are. So B is equal to 71 inches. So this is capital B, which means this is capital C, lowercase c. All right. So now I'm going to set up my law of sines here. And you want to, because right now, obviously, I'm giving you the ambiguous case because that's what it's called. When you know it's a law of sines situation, if it's not the ambiguous case, you know for sure you have one answer. But you have to know how to look at that. And that's what the whole congruent triangle thing. Two sides, non-included angle. Right? So I'm going to take the sine of 75 over what? 51. And that's equal to the sine of B over 71. So I know that the sine of B is equal to 71 times the sine of 75 over 51. Everybody with me? Okay, so let's type that in. So 71 times the sine of 75 divided by 51. Okay. And then what happens? It doesn't work. Well, I mean, because this is what we get, and then we have to take the sine inverse, right? And we get an error. Okay, so the first thing with an error, you should be like, oh, dang, I typed something in wrong, right? That's what I always think. But if I quit, why do you think it doesn't work? Because it's more than one. Look at these graphs over here. Can sine, the y value for sine, be greater than 1? No, you can't, right? So here, the sine, you can't take the sine inverse of anything greater than 1. So this is the case where it gives you 0 solutions. And that's because the sine of B is greater than 1. Remember how I said if you kind of draw it to scale, it might help you a little bit make sense of this stuff. So I really didn't even try here because I just wanted you to think about this. So 75, close enough, right? But this right here is 71. I know that. This is less than 71. And it's not going to work, right? Okay, sometimes it works, sometimes it doesn't, but this is one of those times where it kind of doesn't work because of the angle measure and whatnot, right? But don't go by the way it looks when you're drawing the picture. I'm just telling you that you can kind of help yourself make it make sense. All right, we good? Because the sine of B has to be between -1 and 1 in order for it to work. Everybody good? Any questions? So this is another one of those where I could have tested this by finding the height and seeing the relationship, but really if you just set it up like you do all the rest and you can't get anything and it's because of this and not because you typed something in wrong, then it doesn't have a solution. Okay, we're good? Wouldn't even make a triangle. All righty. So next one. And let's see if I can, sorry. Let me get to something up here. I need to, no. There we go. All right, I need to pull this down. So just for space purposes, I know you probably don't have a ton of space up there, but that's where we're going to draw our triangle. I redid this after I worked this out to give you all more room, but we're going to draw our triangles up here. Okay, so this is here an acute angle. Okay. Our acute angle is given, so we're going to draw our triangle 40, 54, 62. So 40, A is 54, this is 62. So this is angle A, this is little a, this is little b, which means this is capital B, capital C. Ooh, goodness. Sorry, I'm wearing my ID on a lanyard again and a lean. All right, everybody good? All right, so I just start with the sine of A, which is 40, over little a, which is 54, is going to be equal to the sine of B over little b, which is 62. I'm going to let you stop here as far as the work is concerned, as long as you know what you're doing and you don't stop with like the sine of B. You can type things in and get to the measure of angle B right here, and that's just fine. Okay, so to do that, that's going to give me, make sure you're typing with me because there's going to be a lot of storing here. 62 times the sine of 40 divided by 54. Okay. Now what that gives me is the sine of B, but I need B, right? So I'm going to do the sine inverse of that answer and get this number. What should I do with this number? Store it. So I'm going to store it in alpha B. And believe me, as I worked through this, I would forget to store one of them, and I had to go back and type stuff in. It was very frustrating. So angle B, I get 47.563 degrees. So that is one of my answers for sure. Now remember, you could have an acute for angle B. That's the acute angle. And it is 47.563. So the obtuse possibility, got to check it, is going to be 180 minus that 47 dot dot dot. So I'm going to come over here and I'm going to do 180 minus alpha B, and I get 132.437. So these are my two possibilities. I know this is definitely one. This is another one that I'm looking at. So I got to see if it works. I mean, obviously it's going to be less than 180 by itself. I have to use this with the angle they gave me, and 132 point whatever plus 40. What can you tell me about that? It's less than 180, which means there's room for that third angle. So this does work too. Okay, that's my other angle. Now, it's also, so there's two different possibilities for angle B, which means there's two completely different triangles, right? So we need some way to notate this. So since there's two different B's, we're going to call this B sub 1, and that's going to be B sub 2. But I want them both saved. So here's what I did, because there's not two B's on here. Since this is clearly just A, B, C right here, B1 is in B, and then B2, I just put in the one right below it. Like, you can do whatever makes sense to you, but that just made sense to me. You know, with me. So this B1 is B, so B2, I guess, is E. I can't really even tell that. So I'm going to store that in alpha E, and I just knew that it was right underneath it. I didn't care about the letter. So then it's one of my answers. Measure of angle B2 is 132.437 degrees. I get two triangles, right? So this angle A is still 40. Right? So this is still 40, but it's this angle here that is obtuse, and I shouldn't have done it that way. Okay, so this angle is obtuse, because here's my first B, which we got 47 something. This is my second one, which is 132 something. This is still 40, so my triangle would look something like that. And you don't have to draw them to scale or anything. I just want you to see that that's what's happening here. So not only does that change angle B, it also changes angle C and the length of little c. So I'm going to have two for everything. All right, we good? So now I'm going to come back. I got to find angle C for both of them, right? So if angle B, when I have my B1 right here, then the measure of angle B1 plus 40 plus the measure of angle C1 has to equal 180. So in my calculator, alpha B, that's my B1, plus 40, and then I'm going to subtract that from 180. I guess I could have done it differently, and I get 92.437. So the measure of angle C1 is 92.437. 437 or 437. Everybody with me? Okay, so now I've got to find C2. So I know the measure of angle B2 plus 40 plus the measure of angle C2 has to equal 180. So when I do that, I get the measure of angle C2 is, ooh, you know what I forgot to do? What did not do here that I probably should have done? Stored it, yes. So luckily I hadn't typed anything in my calculator. This is where I kept messing up. Like, dang it, I didn't store it. So this is C1. So I'm going to store it, alpha C. Bam. Then I got to go find the other one. So my B2, remember I put in underneath the B, plus 40, and then 180 minus that. It's 7.562 or 63. And what should I do with that? Store it, right? I'm going to store it in alpha F because it's underneath the C, so it's like my C2. You can store them wherever you want as long as you know what you have. 7.563 degrees. Everybody good? Okay, so basically this ends up like two problems in one. Now, I have little a and little b. I have the angles, but I need little c for both of them, right? So that's why I needed those angles stored so that I could go back and use them. Because now I'm going to go back and I'm going to start, well, I'm starting the same way with both of them, but the sine of 40 over little a, which is 54, I need little c1, so that's the sine of c1 over little c1. So when I cross multiply and divide, I'm going to get the length of C1 is 83.933 inches. Give you a chance to go and type that in. Double check the time here. Oh yeah, my watch is fast. Everybody with me? What do I have left to find? Little c2. So the sine of 40 over 54 is equal to the sine of angle c2 over little c2. So in my calculator, I'm going to do 54 times the sine of alpha f, because that was like my c2, divided by the sine of 40, and I get 11.056. So little c2 is 11.056 inches. So you have two sets of information. So this is in the case where you have an acute angle given two solutions, or two sets of solutions. Really. Everybody good? Any questions? It just ends up being two problems in one. That's why it looks like it's so much work. But you got to check them. Do we understand how to check? Yes? Okay. Here's the good news. When you get an obtuse angle, okay? That was creepy. All right. So when you start with an obtuse angle, okay? This is maybe one you want to use a little something that you can check. Because how many different possibilities do you have if you're given an obtuse angle? 2. It's just 0 or a 1. That's it. It's not a 0, 1, or 2 type of situation. So when I draw my triangle, here's angle A. It's 100 degrees, right? So little a is 28. So this is angle A. This is little a. This would be my little b, which is 15. And this is capital B. C. And we're not actually even going to solve this one. We're just going to figure out how many solutions. Okay. So in this case, you can set it up and you can see how many, you know you can't get 2. So if you get 1, you get 1. If you don't get any, then it's no solution. But A is greater than B. What happens when A is greater than B? How many solutions do you get? 1. Here's an obtuse triangle. So again, you got the obtuse angle given. Check this out. This is your 100 degrees, right? A is across from it. A is 15. B is 28. This would be B. This would be A. This is little a. This is little b. So in this case, A is less than B. And since there is no ambiguous case here, 15 isn't going to be able to swing anywhere else. If A is less than B, how many solutions do you get? 0. So I'm going to put no solutions. Or 0, it's fine, either way. If you have an obtuse triangle, you can kind of draw it and see what happens with your picture. With the acute one, not so much because you have the ambiguous case going on. But with the obtuse, this is how you know. And so in this case, if you can tell me A is less than B, so there's no solution, you don't have to have any other work. If you don't remember any of that, it's fine. Set it up, and it'll work out the same way. Like it just won't work because the sign will be less or be greater than 1. But I just wanted to show you that because we didn't have time to work those anyway. All right. Are we good? Any questions? Yes, sir. Oh, yes. Example 3, 2 solutions. All right, let me grab the homework that I thought I had in my hand. Here it is.